So, welcome to today's meeting. If you have not downloaded the MBCEA app yet, please point your phone camera to the appropriate QR code that you are seeing on your screen. Download and engage. We have forums, we have events, we have a news feed, we have ways to direct message with other users. So, it's a really great member benefit. And then I just wanted to also share what the next MBCEA Presents is. That will be October 9th, and that is SEO for builders. So you'll learn how to make your website better. And then our new member quarterly roundtable will be on October 8th. And the Carolinas chapter is holding their golf outing on October 28th. And you can find out more information and register for all of those on our event page on our website. So I am going to stop sharing now and I am going to introduce Kate, and she is going to take it from here. You just have to unmute. I did mute you, sorry. There you go.
Okay,
Should be good
sorry about
now.
that.
Yeah, sorry.
That's okay. I was like, I had the screen up and I was like, how am I going to do that? So as I said, technology is not my thing.
Yep.
But thank you for having us here today to share with our knowledge with all of you. I have Don here. He's not going to be up here all the time. I dragged him up here because he is going to be my IT guy, my questions guy. So if you have questions along the way and you drop them into chat, he's going to be monitoring that and let me know when you guys ask questions. Do you want to introduce yourself, Don? Who you are?
Hi, I'm Don.
He's the
Hi.
president of GWI.
It's Sasha. I just wanted to mention too, you said you might have everybody on speaker view. So if everybody wants to put their views in Zoom into speaker view so that when Kate is talking, you can see her display, her presentation, and the PowerPoint and all that stuff.
Yes, thank you
Thank
for that
you.
reminder. So, participants, look for your view button. For me, it's at the top of my screen. It says view, and when you click on it, change it to speaker view, and then you're going to see Kate's screen.
So we have new technology here that I'm trying to work with. You guys are going to see different angles of cameras. So we're going to demonstrate some of them. You're going to have some PowerPoints, and that this is our way of kind of doing this. I can't share my screen. So if you guys can go ahead and do that, that's great. So thank you, Sasha. And I'm going to say again, if you have any questions as we're going along, please put them into the chat. There's a lot of information today. So as the questions pop up, please put them into the chat and we'll be monitoring those. Probably should introduce myself too, right? So I'm Kate. I am the marketing and sales manager here at GWY. And I've been here for 2.5 years now, almost three. It'll be three. And we also have Audra in the room, and she's one of our in our marketing team, and she's just here doing some behind the scenes stuff. So I have some help here if something should go wrong. Awesome. Okay, so we're here to present. So I'm going to go ahead and get started. If you want to move to your man pose.
Well,
And I'm going to go ahead and start the presentation. So we're here to do structural bolting fundamentals. And we're going to be talking about our structural connections. So there are two. There's welded connections and there's bolted connections, but we're going to be focusing on the bolted connections today. We'll be focusing on the AISC, RCSC specifications, and these are the topics we will be covering. So we're going to talk about bolt storage. We're going to talk about pre-installation verification testing, otherwise known as PIV. We're also going to be talking about bolt tension measuring devices. And we're also going to talk about how to do a PIV test with the 5 installation methods. We're going to run through each one of those. And then we're going to talk about causes for your failed PIV tests. So lots to cover, like I said, so make sure you're asking your questions when you have them. Okay, so storage. These are taken right out of the RCSC. Bolting assemblies must be taken out of protected storage during your installation. So only the amount that you are going to be using that day, you can take that out of that protected storage, use it up. Whatever is not used by the end of that work shift needs to be put back into protected storage. I know this seems like a no-brainer, but you'd be amazed at how much we see when we go visit job sites. This is why we're kind of covering this a little bit, touching base on it. So improper storage can cause dirty or rusty fasteners, which in turn will give you increased torque required to get that bolt to tension. You'll also see bolts failing during your pre-installation testing, but they also will break, whether you're doing it during your testing or your installation. So it's important to have proper storage. And what is that? What does that look like? So this is from one of the job sites that we visited. This is not proper storage. As you can see here, there's cardboard. What do we know about cardboard? It does take on the elements. So if it's raining, your cardboard will get wet. I think the bottom keg you can see there has water inside it. This actually did happen on a job site. So what's going to happen here, these bolts are weathered, they are damaged, and they will see issues. This one's a little better. As you can see, there's probably some scaffolding above it because you can see the sun kind of coming through a little bit. What they decided to do here was use a tarp for the exposed parts. And what do we know about tarps? If you're working in hot weather, once you cover this up at the end of the day and in the evening, it cools off a little bit. It creates that condensation underneath that tarp and will drip into your bolts. And as you can see here, these ones are rusted. So this is not proper storage. This is proper storage. This is very rare to see, but this has 4 walls. They're all in their kegs, and inside those kegs are usually plastic bags. And this is what is considered proper storage. Okay, so moving on. We have pre-installation verification, otherwise known as PIV. You'll hear us say that a lot. Sometimes people will call in and we ask them what test they're doing. Are you doing a PIV? And they're like, what? So we have to slow down a little bit for that. So pre-installation verification, or PIV. This is often overlooked or left to last minute. Most of our customers rely on the inspectors to bring a Skidmore. Come to find out, when those inspectors bring the Skidmore, they don't always have everything that is needed, which also can cause delays. So here at GWI, we recommend getting one, like renting it or purchasing it, a week before the inspector is due to be on site. I mean, sooner if you can, but this will allow you to run through the test yourself, make sure that you have everything that you need to do that. And we're going to actually go over what you need for a Skidmore. So this is what a Skidmore looks like. I'm sure all of you have seen these. So this is a bolt tension calibrator. And we're going to go over some of the accessories that you may need to do that. So when you guys call in to buy or rent a Skidmore, we're going to ask you what type of bolts you have. And, there's TC or there's hex. And there is a reason why we ask that, is because if you take a look at these bushings for a Skidmore, for a TC bolt, we have circular, and for a hex bolt, we have a rectangle shape in there. That's to hold butt head. I don't know if you guys can see that with that glare, but I'll just kind of move it around so you can see the difference between the two. So we'll ask you what type of bolts you're using. We'll also ask you your bolt diameters. You probably can't see that here, but each of these are specific to your bolt diameter as well. We're going to ask you what are the lengths for each of your bolt diameters. That makes a difference because we have short bushings, but we also have regular bushings. So we need to know the lengths. Depending on the lengths, depends on what match of bushings and plates you get. So the plates that we have, this is considered a short plate, which now we call a DTI. These are beveled to be able to use a feeler gauge. We will show you that later on when we get to the DTI installations. But now this is what our short plates look like with a little bit of a bevel in there. This is what a regular plate looks like. So depending on this bolt size, bolt length, this is what we will depend on what we will send you. Also for the bushings, depending on the length, sometimes we have really long lengths of bolts. We have spacer bushings. So this is kind of the same thing here, but what happens is, which you will see later, when you have a tool that uses a reaction arm, it won't reach the reaction bar that fits on the Skidmore. And I will demonstrate that more later, but we want this because when we are putting a bolt in the Skidmore, we want to have our nut flush to the bolt or no more than 3 threads showing. This will allow us to do that for hex bolts. For TC bolts, we have a spacer kit. These come in 6 pieces. They're all varying in different sizes, which will allow you to bring that nut flush or no more than 3 threads. So these spacer kits also come in handy. And these are definitely used for TC bolts, but you can use them for hex bolts too if you only need a few inches covered on your threads. The other thing is if you're using, as I mentioned, a tool that has a reaction arm, you're going to need a reaction bar to react against. So we have these reaction bars that come with some bolts to attach it to the Skidmore. And then last but not least, we do have a C-clip, which holds the bushing in the back. Typically, you see this with the MZ, which we are using an MZ today. So the C-clip keeps the bushing from falling out in the back, these smaller ones. And then we have these bolts that come with it too that will attach your plates to the Skidmore. Okay, one thing that I would like to bring up too is when we are doing testing on the Skidmore, we see it often. And actually, I think we saw it yesterday. We had customers using multiple washers instead of the spacer kits. And we don't want to do that because if you look at a washer up close and you can even put it flat on a table, it's usually not flat. There's a lot of imperfections on these washers. And this does not mimic what you're doing on steel. So you want to make sure you're using the spacer kits, not multiple washers, to get your nut to be flush or no more than 3 threads. So do not use it. You're going to get inconsistent readings on your Skidmore first off, because it's a softer metal. You want to use the harder stuff. So use your spacer kits. If you don't have one, get one. Okay. All right. So the reason why we do a pre-installation verification is to verify that the installation method works, the bolts work, your whole bolting assembly works, the tools, and the people that are doing the installing. We want to make sure all of that works together. This is why we do a PIV. We also encourage you guys, and it actually states that you have to do it on site because weather and your environment does affect your outcomes of your test. So you have to make sure it's done on your site. That is often overlooked, and a lot of people don't do that. So make sure that you're doing it there. We also want to make sure that's done on a bolt tension measuring device, what we just went over, a Skidmore. Most people know it as a Skidmore. So making sure that you do it on that, you have to make sure it's also calibrated. So if you get a Skidmore either from us or from Skidmore, you will see this certification in there, and it lets you know that it's been certified, been calibrated. It tells you the date that it was calibrated on, and it'll tell you when it is due. I don't know if you guys can see that. It's probably a little, there you go. So we have that to look out for too. And like I said, these are usually looked at last minute, and it's always a rush to get them in, and everybody needs it done yesterday. So make sure that you are doing this when you know that you're awarded a job and you have a Skidmore, just take a look at it. Make sure that it's been calibrated so you can send it in. These things are expensive to ship because they're heavy. So if you know ahead of time, you don't have to do next day air. You can send it regular ground. When you send it in, we don't need all the accessories. We need just the unit. So make sure you send in just the unit. We don't want to be responsible to look after your bushings and your plates. So make sure you keep those on hand with you. And then when we do our PIV, you need a minimum of 3 bolt assemblies to test, a minimum. Sometimes you need more if things need to be worked out. You'll need more bolts to test. All right. We're going to go on with the first installation for PIV. So this is the calibrated wrench installation. This has been in the RCSC since the first one back in 1951. Torque and tension relationships are not allowed by the RCSC specifications, and you're going to see why in a moment. I'll give you an example. And these have to be calibrated daily, just so you know. These tools need to be for every installation tool. It needs to be calibrated daily. For every combination of bolt, nut, and washer lot, you have to calibrate them. This installation method is very rarely done the correct way. It's hard for most people to understand. So this is why this method will not be in the 2026 RCSC specification. So that is coming out next year when the new one comes out. And also torque alone is not a valid measure for fully tensioned insulation. And a good example of that is this. If you take the 1-inch A325 bolt and you install it to 300 foot-pound torque, if you look at the 3 different types of bolts that we used, we have dry. So this is something that's been left out of the keg. This has been exposed to the environment. Then there is as received. So this is just as it comes out of the keg, and then we lubricate it. So if you take a look at the lowest number, which was 14 kips or 14,000 pound force, and the highest was 38, you can see that there's a 24 kip or a 24,000 pound force, variance in tension. So it lets you know that even though you're at that torque does not mean that you are at that tension. So there's no relation between the two when it comes to the RCSC. They won't allow that. So that's a good example. Okay, moving on to this second method, which is the combined method. This was first allowed in the RCSC in 2020. This is one that uses torque and angle. And this wrench needs to be calibrated as well, the torque wrench. I'm going to go slow through this one because there's a lot to take in on these steps. So if you need me to clarify anything, please just stop me and let me know. So what we're going to do is we're going to do initial tensioning, which we consider snug. So you're going to do the initial tensioning. What we have to point out here is that the nut is the one that needs to be the turning element. It has to be the nut. There are cases out there with the hex bolts that they will do head. We don't recommend it, but head tightening for this method, it has to be the nut. So when we do this initial torque, that initial torque is given to you by the supplier of the bolts. If they didn't give you that torque, if the supplier didn't give you that torque, there is a torque table for this method in the RCSC, which is table 7.3. So for step 2, it's the intermediate verification. So once you do step 1, once that's complete, you have to verify that the tension on the Skidmore is less than the kips that are specified in table 7.2 in RCSC. And then the pre-tensioning, this is where you're going to do the match marking. And then you're going to apply the rotation to the assembly using the rotation table 8.2. So this is not the normal rotation that you would use for a regular turn of nut rotation, because the snug for the combined method is much higher. So this is going to be a lower rotation. And step 4 is final verification. So once the rotation is applied, then we have to verify that the Skidmore gauge is at minimum tension or above minimum tension using table 7.1 in the RCSC. So this is where if it doesn't pass the PIV, this is where you have to determine what the cause is why it didn't pass the PIV before you can move on or before you can even use the assemblies in your work. So from here, if it passes, then you need to repeat 2 more bolt assemblies from the same lot. So any questions there? No? Okay. It's a lot to take in for that one. There is. Yep.
Are we supposed to be seeing, oh wait, that's for somebody else. We're supposed to be seeing Kate.
You will eventually. You will see me eventually. Somebody else was asking that. Okay, so
Switch to me.
yes, you guys will see me eventually. I'm going to be doing some demonstrations for you. So the next step the next installation method we're going to cover is tension control, or TC as some people will call it, also known as the twist off installation. So this was first allowed in the RCSC in the 1970s. We use a shear wrench to twist off the spline. And these do not need to be calibrated. We often get that question, I need to send this in for calibration? These do not, because the tool itself doesn't have technology in it. It's actually the bolt that does. So we, always say the technology is in the bolt. You guys are familiar with the TC bolts. So I'm going to share with you what a shear wrench looks like. I know a lot of you have used these, but I'm going to just kind of walk through it anyway. This is our S61. These come in different sizes, and they have an inner and an outer socket. Okay. One thing that I will recommend is that you guys check your brushes often when you're in the field. It's easy. You just peel this back. You use a screwdriver to get your brush out, and you just take a look at it. You'll see the wear and tear, the miscoloring. I mean, these are very easy to replace. You can do all that right there on site, or you can just send them in and have them looked over, repaired, cleaned up. And then we also have a little trigger here to release the spline. So when you shear off that spline, it stays inside to prevent it falling from below to the people below, so you're not hurting anyone. So it stays inside, and then all you have to do is release it with this little trigger press to get that out of there. So you can buy these sockets separate or as a set. So there's an inner and there's an outer. So the inner attaches to the spline while the outer attaches to the nut. And they both rotate. The other thing we have here is a nut buster. I don't know how familiar you are with this, but this mimics the spline. So we call these reverse sleeves as well. Nut busters are reverse sleeves. How this works is you place it on the nut and it fits right inside the inner socket. And then all you do is press the trigger, and then it reverses the nut off the bolt. So you can remove the bolt. This is good to take this off the Skidmore. It's good to do some, to have for rework if you need to have rework done on the site. These are also good to have. Okay. The steps for the PIV for TC is to snug. So snug often gets skipped with the TC. And one of the things to think about with that is, yes, in the Skidmore, you don't have multiple plies, but you do when you're out in the field sometimes. So you want to make sure you're doing that, because snug, the definition of snug is snug tight and or tight iron, right? Full effort of an iron worker and or tight iron. So you want to make sure you don't skip this. We see it a lot. Snugging is important, and it's specified in the RCSC for every installation method. So make sure you're doing your snugging. You cannot lube these. These already come lubed, but you cannot add more lubrication. If these have been exposed to weather, they're rusted, you just have to throw them out. So not a good thing to lube those. Okay. Direct tension indicator, otherwise known as DTIs. going to show these to you. So these were first introduced to the RCSC in 1974. They rely on the bumps. So if you can see these, maybe if I move them a little closer, they do have bumps on here. There are two of them. So we have some that have no filling, and then we have some that has filling. So this is silicone, filled with silicone. So these are good to have, the ones that have silicone, these are good to have, so you don't have to use a feeler gauge. There is a way to do that, and that's in the RCSC specifications for 2.12.6 if you don't want to use a feeler gauge. But we're going to show you how to do it with the PIV installation testing, so we're going to be using a feeler gauge. So that's what these two differences are. So no silicone and silicone. Okay, so it's a simple load cell and it's not a torque-based installation method, just so that you know. And I'm gonna show you the slides, and then I'm gonna set up the Skidmore so we can show you and demo how to do one of these. So,
You're on twist off.
oh, I'm still on twist off. Sorry, I went the wrong way. Thank you. One more. Sorry about that. Thank you. All right. So as you can see here, snug again, right? So we have snug tight. Then we have step two. I'm going to demo all this, but I'm going to walk through it really quick first for you. So step two is we're going to tension the bolt to 7.1 in the RCSC. So that is for the minimum tension. So we have we're going to be doing a 3/4 A325. So we need to get it up to 29 kips. So we're going for step two, we're going to bring it up to 29 kips. And then we're going to verify with a feeler gauge that we have less than half refusals. So I'm going to explain to you what a refusal is. So let's go ahead and let me see if I can get you the right camera angle here. Okay, so we have a feeler gauge. That's what these look like. And I'm going to go ahead and I'm going to set up the Skidmore, and I'm going to show you how to use these feeler gauges as we move along with these steps. So I'm going to switch you over to the Skidmore so you can see how I set it up. So I'm going to put the bushing in first. We don't want to hammer these in. They will fit in nicely. You just have to wiggle them a little bit, make sure it's flush here. We're going to use the C-clip like I had mentioned to hold that in. And then I'm going to attach the plate. And because I'm using my GNR, it has a reaction arm, I'm going to go ahead and I'm going to install the reaction bar. Okay. So I'm going to put the bolt in. When we put the bolt in, so you want to make sure it's seated properly. So if I give it a little bit of a twist, did you see how that kind of popped back out? So you want to make sure that it is pulled all the way through. I can't tell you how many times we've had these bushings come in and the bolt wasn't seated properly and the whole back end of that bushing is just, totally destroyed. So make sure you do that. I'm going to use a spacer so that I can bring this to making sure that this is, I think this is the right one. So I can bring this flush or no more than 3 threads showing. I'm going to install, after I put that spacer in, I'm going to install bumps out. Then I'm going to put the regular washer on there, making sure the writing is out. Then the bolt, the nut. We're going to, just hand tighten it. We have no more than 2 showing there. No more than 3, it's only 2, showing. So I have that. So the first step, as it says, is to snug. This is a 3/4, so I'm just going to use a spud wrench. Okay. So we tightened it. Next thing I'm going to do is I'm going to bring this wrench, this GNR over. See if I can do this without knocking everything over here. And I'm going to plug it in. Here, I'll do this so you guys can actually see what I'm doing. I'm going to plug it in. Okay. Right. Make sure my tool is going forward. And because I have a reaction arm, we want to keep our hands away from this. It's painted red for a reason. But because I have a reaction arm, this is why I used the reaction bar. So I'm going to switch you over to the Skidmore so you guys can see up close what I'm doing. So the step is to bring it up to tension. So like I said before, it's a 3/4 A325. RCSC wants us to bring it up to 29 kips. So I'm going to go ahead and bring this up to 29. So the next step here is to use your feeler gauge. So when you're using your feeler gauge, you want to look between the two washers is where this feeler gauge needs to go. Now, a refusal is if this feeler gauge does not touch the shaft, so the bolt shaft. If it touches the bolt shaft, then it's an acceptance. So I'm going to keep it in refusals for you. So at this stage, when we're at minimum tension, you have to have less than half. So there's 5 bumps on this 3/4. So we need to have 2 refusals. So it has to be less. So I'm going to go ahead and I'm going to do that. I'm going to step in front of this camera here so I can get a good. So there's 1 refusal. And I'll show you what that looks like actually. Let me go back there. So I can't even get that in. So that's a refusal. Then we have this one I have to bend a little, but this one went all the way in. This one goes in all the way. Let me see if I can, there's got to be a better way to show you guys that. So this goes all the way to the shaft on that one. So that is not a refusal. So there's 1. Because I don't have my glasses on. There we go. So there's 2. That one doesn't go in all the way. As you can see, it just kind of just goes in just a little bit. So that's a refusal. There's 2 there. 2 refusals. I have to do this off to the side, sorry. And then that one goes in all the way. So there we go. So we have less than half refusals. So now what we have to do is bring it up until we get more than half refusals for it to pass. So more than half means 3 or all. As long as you get 3 or more, you are good. So I'm going to go ahead and I'm going to do that. I'll just feather it up a little bit. Okay, just a tad, not much. Now I'm going to do the feeler gauge again. All right, I know we had one go in here. Oh gosh, that's not even going in at all. How about this one? Yeah, if you guys need glasses like I do, this really stinks. Here we go. Yeah, that one's not going in. That one's not going all the way in. That one's not. And one more. And that one's not either. So this would be a pass. So since this passed, then we would need to do 2 more to be considered a pass for your PIV. Yes, do you have a question?
Somebody's asking about the different feeler gauges for building versus bridge work.
Ah, yes. So it really comes down to the engineer record. I'm sorry?
Repeat the question.
Oh, yes. So someone is asking about the different feeler gauges for for bridges versus buildings, correct? Or steel structure. Gotcha. So typically the bridges are 0.005 and the buildings are the 0.010.
015.
015. Yes, sorry, it's 0.015. Um, That's only if the EROR says that, though, your engineer of record. Typically, what Applied Bolting, who does the squirter DTIs, they say 0.005. Use that all the time, unless specified by the EOR. So, which is great because it's it's thinner. It's the way to go. So we use 0.005. Hopefully that answers the question. Is that good? Yeah. Okay. Thank you. All right, let me just get this tool out of the way here before I continue. So I don't trip. Safety first. All right. Okay. So any other questions there? No? Okay. All right. So we will move on to the final installation method, and that is the turn of nut. So this has been in the RCSC since 1962. And what we do with this is the degree of angle to rotate a nut. And what that relies on is the bolt diameter and the bolt length. And this wrench also does not need to be calibrated. So how do you know when it needs to be worked on? Well, that's when we tell people if it's not reaching the angle that you have it set at, that's probably when it's time to bring it in and have some work done on it. So it doesn't need to be calibrated. Make sure I go the right way.
The bolts, they were got the oil on.
Oh, somebody asking a question?
Sure, that one.
Oh, his iPhone is unmuted.
That's why they heat.
Oh, okay.
He's muted now.
Sounds like someone was asking a question. Okay, so now we're gonna demonstrate the turn of nut installation. And so basically, again, you're gonna snug. You're gonna determine the angle that's needed to rotate. You're gonna do your match marking, and then you're gonna rotate it to the specified angle. So I'm gonna walk you through that. Before I do that, I am going to take off this bolt, and then I also have to switch it over. Make sure. Here we go. Okay, so what I'm doing here, and maybe I need to change the camera angle a little bit for you guys so you can actually see. All right, so what I'm doing here is I'm going to switch this plate up because I'm not doing a DTI, and the bolt that I have is longer, so I need to put on a regular plate. So I'm just going to flip this around. Maybe I should just take that thing up here. So as I said before, these are all according to our bolt lengths. So what I'm going to do is just flip this around just to make things quicker. Okay. Yeah. Okay, I'm going to use a tan tool, which has a reaction arm. So I'm going to put the bar back up. All right. So now what we have here is a TN tool. Gotta learn my camera angles here. As our TN tool. So we have an angle setting dial here in hundreds, tens, and ones. We're going to be doing a 3/4 A325. So for us, and the length is less than 3 inches. So we're going to do a 120 degree. So you want to make sure that this is set at 1, the tens are set at 2, and the ones set at 0 for 120 degrees. The thing about this tool is that there's an internal counter. So when you press that trigger, you got to let the tool do its thing. If you press the trigger, let it off, then the internal rotation counting starts all over again. So you could over rotate if you do that. We're used to doing that because a lot of people use the impact wrenches. They're constantly feathering the trigger. With this tool, you cannot do that. You just let it do its thing. Set it, press the trigger, and let it go. We have a reverse on the back, which you'll see will come in very handy to get it off the skid more, to get the bolt off the skid more. Do not carry your tools by the cord. We see this all the time. We are a repair house as well. So you should see some of the things that happen to these tools. So don't carry it by the cord, please. And these bar sockets are interchangeable. And they're also painted red. This is painted red for a reason because this is a pinch point. You can lose your fingers. It's very dangerous. It's also another reason why to have a reverse, but just keep your fingers away from the red. Okay. All right. So what I'm going to do here is I'm going to install the bolt. Making sure it's seated properly, giving it a little wiggle, make sure it's back there all right. Put this on. So that's my spacer. And then I'm going to put the washer with the writing out. And then the nut. Okay, hand tightened, it's flush, so it's ready to go. First step is snug. So I'm going to go ahead and I'm going to snug it. It's a 3/4, so I'm going to use a spud wrench. Typically anything like 7/8 or above, I always recommend people just to use an impact wrench. It just makes it easier, and your snugs, when you do that, are consistent, because part of this TN tool, or excuse me, turn of nut method, is you want to practice your snug because you want to replicate that on the steel. So this is a great place to do that. So I'm going to go ahead and snug it. Give it my full effort. There you go. Don't judge. Look at the numbers. The next step after we do that is to match mark. So when you are match marking, it's important to only do half of the bolt. The reason why we say that, there's going to be instances where you have a length of bolt where you're going to have to do 180. If you do the whole bolt, you're never going to know where you started from, right? So we want to make sure we do half of the bolt. So I'm going to step in front of the camera here for a moment so I can get a straight line. Even then, it probably won't be straight. I'm not very good at drawing straight. So there is a straight line. So you want to do half of the bolt onto the corner of the nut, onto the steel. So I'm going to do one more mark. It's not required, but we like to call it the show off mark, or we like to call it the inspection mark. And the reason why we do this is just to show you how accurate our tool is. So once you set the dial, it will give you the same results, and it's repeated every time. So we needed to do 120 degrees. Every corner of the nut is 60. So we have here 60, here's another 60. So that's 120. So we need to mark, put the show off mark or the inspection mark here. As I said, it's not required, but we do it for demonstration purposes. Okay. So now I'm going to plug in the tool. All right. Make sure the tool is going forward, which it is. And I'm going to go ahead and I'm going to press the trigger and let it do its thing. It's going to stop on its own. All right. So as you can see, for an A325 3/4, for the kips that it needs to be at is 29 kips. So what are we at? We're at 32. So this would pass. And not only would it pass there, but it also passes the full rotation as well. So not only do we get it here, but we also have to verify the rotation. So we've got the full rotation and we got the kips. So this would pass. So we'd have to repeat 2 more bolting assemblies from the same exact lot, but you're going to use the same level of snug and you're going to use the same rotation. So that is how we do the turn of nut. We have a question.
No,
Yes,
I have something.
you have something yet. Okay.
I was just gonna say, mention that minimum tension.
Minimum tension or above. Yeah. Correct. Yes. Good point. Because we do get that a lot too, where people will call in and say, you know, I'm getting much higher than the kips that are required. That's what we want. We want it minimum or above. What is too tight? It's when the bolt snaps. So above is great. The tighter, the better. So one of the things that we like to do when we go and do training on site is we have, I mentioned snug. Snug is very important. Typically when the turn of nut method doesn't go well, it's usually coming down to snug because it's not being done properly. So one of the things that I like to do when I go and do training with people is I have them use an impact wrench, hear what it sounds like. I have them do it a couple of times so they can see where the gauge ends when they do that. And then I cover it up and I just cover the gauge because you don't have it on steel, right? So they've practiced it. They know what it sounds like. They know what it feels like. So I cover it up, have them do a snug, and then we uncover it. And it's exactly where they were when they were practicing. So that is very important. Having your workers do that is super important when you're doing turn of nut. So just a little tidbit there for you guys to practice. Okay. Get my thing here. All right. So any questions from that? No? Okay. Perfect. Okay. So reasons for failed PIV tests. So usually, like I was just saying, you know, typically when something goes wrong, it's because snug isn't done correctly. That's a big one. Steps were skipped. We do see that often as well. But just going through, checking out why, you know, go through your method again. How are you doing it from start to finish, and just making sure you're pausing in between each step to make sure you're doing it properly. So going through your steps, improper bolt storage, as we talked about earlier, and I showed you, you know, this is a big one too. Just it being out in the heat throughout the day can affect it too, especially if they're already, like those TC bolts are already lubed. And we see bolts snap a lot because it's hot and they snap before they actually reach tension and shear off those splines. So making sure that you are paying attention to all of that when these are failed. Tool maintenance, that's another big one. Like I said, those brushes are pretty easy to do unless you have battery operated. There's no brushes there. Those are brushless, but tool maintenance. We always highly recommend, as I mentioned, we are a repair center here too. We try and encourage everyone to send their stuff in when they're done with each job. So that when the next job comes up, you're ready to go, you're ready to hit the ground running, and there's no, you know, issues where your job site's down. So make sure you keep up on your tool maintenance. And then I mentioned it a little bit already, weather, you know, any of that stuff, heat, cold, condensation, rain. I mean, you really probably shouldn't be using these tools out in the rain anyway. And then lubrication. So these, sometimes you just need to lubricate your bolts, and some of them, there are exceptions. As I keep mentioning, your TC bolts, you cannot lube. The bolts that you use, the grade 144, the ASTM 53, excuse me, F3148, that's what they use for the combined method. You cannot lubricate those. And then anything that's considered an alternative design fastener. And this is just hitting home again. You've already seen this slide, but just showing you what lubrication can do, especially when you're using torque. It does lower the K factor. It's kinder on your tools. Typically, anything that's an inch or above for hex bolts, we do recommend you lube your bolts. There's wax, there's spray, and every little bit helps. It saves on your tools. I mean, your tools are a huge investment. Be kind to them, and lubricating is one way of doing that. And then we also offer training. Like, we go on site and we do what we're doing here today. So we're available for that. This is the email that you can reach out to, and we'll get back to you to schedule that. That went a lot quicker than I had expected. I thought there would be a lot more questions. Am I that thorough?
That's what I always say, Kate, when there aren't any questions. I'm like, you did such a good job. There was nothing left.
I'm going to take it that way.
That's I agree. I think that's the answer. But no, we absolutely have some time built into this for questions. So please do not be afraid to ask. There are no dumb questions. So please ask. You've got the people here that can answer any of your questions on this subject. So either unmute and ask it or type it in the chat. We're here for some additional time for questions.
Yeah. One of the things that I kind of skipped over too is, there are multiple ways to do multiple tools that you can choose from to do these installations as well. And I know, I don't know how much you guys are seeing of DTIs now, but we have a quick, easy way to do it other than all the steps that I just went through. Kind of using the TN tool that I just demonstrated for the turn of nut. It's coined as absolute accuracy. You get the same thing over and over again with that tool. So you get the repeatability, and it's great to do it when you're doing a DTI installation. So what happens though is a lot of people tend to mix the two up because they're using a TN tool. They kind of mix in the turn of nut at the same time, and it's not that. You're doing a DTI, but you're using a TN tool to do it. And you just dial it in and you get the same results every time for DTI. So just kind of putting that out there for you guys too. There's other methods to installing it other than a torque wrench.
I got a question on your lubrication.
Yeah.
So a lot of the time our supervisors will unload our building packages, whatever, on site. And a lot of those bolts sometimes are left out in the elements. Is there a manufacturer's note included with that? Or is it common knowledge on which bolts can or cannot be lubricated?
I know that, did somebody else say something? Okay, it must be me echoing. So as long as it's not, a TC bolt, because you cannot lubricate those, you have to remove those and just get rid of them. Can't use those. I do know that when you're doing turn of nut, it's okay to do that. And I do know that when you're doing your torque, it's okay to do that after they've been out. You mean as it's been sitting out there in the steel, right?
If it's been, for torque, if it's been written into
The specs.
You can lubricate them, but otherwise.
Unmute yourself so they can hear you. You can answer that too.
There we go. All right, so turn and nut method of installation, you do not have to worry about lubing the bolts. You can lube them. It's not a problem. It's no issue because you're relying on tension only. When it comes to TC bolts, no, you don't want to lubricate those. The torque method of installation are not combined. That too, unless on the torque method of installation or calibrated wrench method of installation, unless it's written into the bolting specs, no, you can't lube them. After the fact, if they've been exposed to the weather, you can go in and ask to have that changed in the bolting specs if that's something that you want to do, from what we've seen out in the field with people that we've worked with. And I don't know, Luke, does that answer the question? Did we hit that? Because it kind of started with Kate and then moved to me. So I just want to make sure we hit in on what you were asking.
Yes, sir. I think that covers it.
Okay.
Good questions.
Anyone else?
That's easy. Awesome.
Great, excellent. Well, then we will say that we covered that subject thoroughly. We want to thank Kate for the demonstration, the cool camera angles. I know this is a difficult thing to do virtually. Oh, hold on. We've got one question from Eric. Don, you want to address that? Or maybe it's just a
Yep,
comment.
I'm just gonna read it first here.
Yep.
I gotta.
I'm gonna mute it so that.
It could, Eric.
What is the
So
question?
the question is, if the TC bolt testing was performed in a controlled environment at no less than 45 degrees Fahrenheit, but the installation is being carried out outdoors in colder temperatures, does that affect the validity, you know, that word, of the testing or
Validity?
required additional, yeah, that one, or require additional verification under field conditions? Weather does play a big factor in this because the bolts in warmer weather will soften and it takes less torque to get that tension. So the temperature of 45 degrees, and it's not at freezing, it's not that cold, but when you go out and it's like 20 degrees or 15 or 10, it can affect some of those results that you're getting. And one of the things that's why we say is that you should definitely be doing the tests in the same environment that you're doing the installations.
Yeah.
I know in some cases it's not going to be the case if you've got like New England weather and in the morning you've got 5 below zero, and then in the afternoon it could be 40 or 50 degrees. It's just the way it is in New England. So it's hard to get that exact every single time, but you definitely want to try and make it as close as possible. Does that help? Give me a thumbs up.
Yes, like my main question will be like, for example, we have a project in our company in Des Moines, and we were like, I was doing the testing on that temperature, but after the guys, they were like snapping the bolts under 10 degrees, like, and during the inspection, like one of the guys there were saying like, you are doing testing in a controlled temperature, and after the guys they are doing the snug tight and then all the process in a lower temperatures. Like how does we can track or to get the same test results, you know, because we're testing in one temperature and we are installing in another temperature.
Yeah, again, you want to do that. If it's outside is where you're doing the installations,
Yeah,
that's where
correct.
you want to do your testing. You want to do your testing in the same condition. You're going to get different results.
Because the main
Possibly.
thing, yeah, sorry, but the main thing is like, for example, we were talking with the supplier and he was saying that you cannot do the testing if it's less than 45 degrees. So how we are
They said you can't do the testing?
correct.
The bolt manufacturer said that?
Yeah.
Yeah. I haven't run into that. I don't know. I mean, we're friends with a couple of the bolting manufacturers out there. We can certainly ask to verify that, just to see what their opinion is on that, or what their specs are and rules and regulations are around that. I have not run into that.
If you
Okay.
want to send me an email, so I can get you the answer to that, that would be great.
Thank you.
Absolutely.
Yeah.
Yeah, no problem.
Hey, I got a question.
Yeah.
You hear me?
Yes, Carlos's phone, we can hear you.
Okay, so if we do the installation on all the boats and we got a pretty good size building, and we're just gonna tension those boats like a month after the installation, that affect anything?
Does that affect anything?
Yeah. To get the
As
same
far-
result,
Oh.
to get the same result when we do the testing?
So typically, well, are we talking TC or are we talking HAPS?
Yes,
TC?
yes.
Okay. From my understanding, and Dawn, maybe I should let you do this so that there won't be any confusion when we do this. The look on Dawn's face. Do you want to address that? Go ahead. Oh, do you have to unmute? Sorry.
I do. I don't
Sorry.
want the echo, so sorry. So if the TC bolts are being just snugged up in the as is condition for that day, and a month later they're going to be tightened, will it affect the installation or the results in the installation? Not all the time, because your bolts are installed either in the steel, they're covered, by between the threads with the steel of the hole that it's in. So it's usually okay. They do not recommend a month out. I mean, I think tops is like a couple of weeks or a week or something like that, or even a few days, depending on who you're talking to. But we've seen people leave them in there for a month. I don't recommend that. But we've seen it where it doesn't really affect it because the bolt hole itself is actually protecting the bolt and those threads that are actually where the stretch is happening in that bolt.
One of the things too that we do is we'll take a rusted TC bolt and we'll put it in a tension calibrator into Skidmore, and we will follow the steps of installation, and you'll see that the spline will shear off, but when you take a look at the measurement, it's not where it needs to be for KIPS as minimum tension. So it's important to do that kind of testing. And I've seen it too, where some people are like, oh, it's okay because, it sheared off and it's fine. But after it's been sitting there for a month, you don't really know because you don't have, your KIP readouts when you're out there in the field. So, I mean, typically we don't see them sitting that long. But the fact that the part that's going to be tensioned is all covered, and sometimes it affects it, sometimes it doesn't. It's hard to say, but just keep that in mind too. Just because the spline sheared off doesn't necessarily mean it's at tension after it's been sitting there for a while. I know that doesn't answer your question, but we don't know because there's no way to read your KIPS while you're out there.
Any other questions?
That's great.
Okay,
All good
very good
questions.
then. Yep.
Awesome.
Thank you then, again, for
Thank you.
the camera angles and figuring out how to modify presenting not in person, but doing it virtually for us. We do really appreciate you putting in all that effort to demonstrate all those for our members. And again,
Yeah.
thank you, and have a great rest of your day.
Thank you for having us. Thank you.
Bye-bye.
Bye.